Hello. Thank you for taking the time to check out this video here today. Today, I'm going to talk about graphing and how we use graphs for physics and some of the rules that I teach with my graphing here so that we can get a good solid graph as well as getting consistent graphs throughout the whole class. So the very first things I want to talk about is just a couple types of graphs, the three main types of graphs. There's plenty of other types, but these are the three big ones that we see a lot of the time. The first one is a bar graph, and oftentimes we do a first lab, and I will just prompt my students to make a graph based on the data, and that's all the information that I give them. And a lot of the time, they will go straight to a bar graph. Bar graphs are fine. However, what they do is they really are used to compare different categories. So maybe we're looking at just like the number here, number of, so however many we have, and maybe it's muffins and bagels, and with donuts. There we go. Right. So when we're looking at different comparisons between those three different categories of that, and it's really the big keyword there is it is a comparison. And one thing to note, a bar graph, it could be vertical or horizontal. So depending on how you look at it, just to clarify there, not all of them look like this, but bar graphs are used for comparing things. Another type of graph that I see often used is a pie graph or a pie chart. Pie charts, pie graphs are also used for comparing rather than comparing, maybe a number of or comparing to some certain thing. We use a pie chart, pie graph to compare percentages. Again, there's that keyword of comparing. This is just looking at that graph, being able to see, okay, this one has more, this one has less. So again, now if we use the same thing, this red part here as muffins, we have a higher percentage of muffins. Then we have some bagels, which is a little bit, which is less, and then a little bit less than bagels. We have donuts down here. And so we can easily see that comparison. Now, for physics, and most of the time other sciences as well, but for my physics classes, we like to not necessarily compare, but rather look at a relationship between two things. So rather than being able to compare all three types of these, I would maybe look at the relationship between muffins and bagels. Right? It's kind of a weird initial analogy there, but I want to look at the relationship between the two rather than just compare. And that maybe is confusing right now, but let's take a look at how we do that. So rather than using a bar graph or a pie chart, we're going to use a scatter graph or a scatter plot. A scatter plot still has two axes on it. We have the X and the Y, or the independent and the dependent. And then we get some data points on there. Each data point represents the corresponding data point from our data table. So in this case, we have a certain number of muffins means that we have a certain number of bagels, let's say. Right. And then, okay, I increase the number of muffins that I have. Well, that also increases the number of bagels that I have. We increase even more, and I increase even more, and so on. Right? So each one is a relationship there. Now, to look at this actual relationship, we often will put a best fit line. Let me get a slightly different color here. Let's go purple. A best fit line on here. And so a best fit line kind of goes through close to the data points. And this line, this is the relationship. And what this lets us do that the other graphs don't is it allows us to make predictions about future events or past events. I can extend this line out. I could keep on going. Let me try to get right on top of it there. I could keep on going really, really far out, and I could extend my axes here, and I could look at this data point all the way out here. And I can make a prediction for, okay, if I have this many muffins, let's say it's all the way up here, like 100 muffins, well, that's going to be however many bagels, right? Doing that on a bar graph, I can't really make that future prediction because I only get a comparison. I only get to see, okay, if I have this many muffins, I have this many bagels and this many donuts. I don't get to see a trend as things change. Whereas scatter graph, a scatter plot makes that really easy for us to do. So the big key word here is the relationship. Seeing the relationship between two variables. Okay. So that's really what physics is all about, is being able to look at given information and then make a prediction about what's going to happen. That's what a lot of our physics, I guess I should say. That's what a lot of our physics 1, intro physics, whatever you want to call it, is about, is this kind of idea here. Using these graphs is going to be super important for us because we're going to build our basic building blocks, what we call the kinematic equations, from graphing data, collecting data, analyzing the relationship between two variables. We are going to get the relationship that then builds to our equations that we can then use to calculate things. We don't have to graph every single time. So that's where this comes in. Now, let's take a look at how we actually make these graphs. What does a good graph look like? Whether we're graphing for physics or we're graphing for another class, I have a couple main rules that I cover with a proper graph that usually covers you pretty good. And, your teacher might have some slightly different things that they like, but usually these things are going to keep you pretty safe and good. So for a scatter graph, that's what I'm going to talk about here. A scatter graph, you need data. That's the first and foremost thing. So this here is my data table. From that data table, we get all of our data. So you'll have this filled in with numbers. For example, the X value here maybe is 1. And then for a good science graph, we usually want to do at least 3 trials. So we measure it multiple different times, then we calculate an average. So let's just say it's 2, 2, 2. That means our average would be 2. Okay, easy enough. And then let's go on a few more. Here we have, just so we see, we have 2. Let's increase by 1 every time. So our trial 1, 2, and 3. Now, when you're actually collecting data, you probably won't get the exact same number in each trial, and that's okay. That's why we do the trials, because we have a little bit of error. We talked about previously with our measurements, we always have a little bit of error. And by doing multiple trials, it helps us get closer and closer to be more accurate, to get closer to that actual measurement. But for this, I'm just going to assume that I get all the same, just to simplify things. Okay, so I get some data in here. Let's do one more, just something like that. Okay. So I have my data, calculated all of my averages. Now, what we're going to do is we're basically, once we calculate the average, I don't care about anything else in between. All I care about is my X values and my averages. That's why I calculate my averages. I see a lot where people will graph each trial on their graph, and they'll end up with something like similar to this, where we have 3 different lines. This is trial 1, trial 2, and trial 3 there. And that's great. That shows us this relationship. But again, we do the average specifically to kind of combine those 3 trials all together, and then to simplify our data, to make our data better, hopefully. If we have good measurements throughout all 3 trials, it'll make our data better. So we want to graph that better data, that average. So these get pulled and put onto our graph. Typically, your X value is going to be in the far left. Now, this is not always true, and this is a kind of annoying, tricky thing. It's not always going to be true. Not always is this going to be your leftmost column, the X value here. Oftentimes, we'll measure time as our trials. time is one that always goes on the x-axis. I'm just going to make a little note of that here. And it's a little bit of a spoiler there for what's to come, but it's important. Time is always on the x-axis. Okay, so whenever we graph time, it will always go on that x-axis. Other times, if time is saying time a lot, if we are not using time, seconds, minutes, hours as a measurement, whatever is in the leftmost column of your data table is usually going to go on our x-axis here. This is what we would call the independent variable. We already talked about that up above. This is the independent variable. Then our average value will go on the y-axis, right? We have the y's there. This is what we call the dependent variable. We can simply define the independent variable and the dependent variable. Independent variable is the variable that we control. We make those changes to it. The dependent variable is oftentimes the thing that changes in response. So as I change x, how does y change? And that can help us build our graph there. So I have my x, my y. My axes are labeled, okay? I include an axis label. Right now it's simply just x and y, so those are labeled. Then we include our data points. So whatever data points they are, we have little dots there, however they fit. We put them in like so. That's more than I have in my data table, so let me just erase it so we keep consistency there. Then we're going to include our best fit line. Best fit line, oops, that's the eraser. There we go. Let's try this again. Our best fit line is the line that best fits our data. Now, best fit line, again, best fits. This line here that I drew does not really seem to match the trend that my data, my 3 data points here are showing me. This line here also doesn't really seem to show that. And I keep erasing stuff. And that one also doesn't, right? We want to get as close as we possibly can to going through all 3 of our data points. Oftentimes, we'll start at 0, 0 down here, the origin of our graph. Not always, and that's totally fine. We want that line that best fits. So notice here, if I start at the origin and try, I can't really get a line that looks great. That one looks pretty good, but I would say that this one here, nope, sorry. Didn't quite get that. Let's try that again. Nope, I keep going too high. Let's start a little lower. There we go. I would say that this one looks a little bit better because it goes through all 3 points. That's kind of the ideal thing there. So our best fit line, we always want to include. So again, axes labeled, y-axis, x-axis labeled. I've got a best fit line for all of my data. Then I need a graph title. The graph title tells the person looking at your graph, because the goal with science is to share the things that you find with other people. If somebody were to just look at a graph without a title or without axis labels, it becomes very confusing. They don't really know what you're trying to tell them. So you want to include a graph title. The most basic graph title, the simplest one, and the one that I just usually have my students do for ease. I'm going to quick adjust to the camera. There we go. For ease is we just say y versus x. Okay, so whatever our y value is, let's say that the y here is donuts, just going back to that same example, and x is muffins. So I would say donuts versus muffins. Now, this is not a great title. It's not game-changing, anything like that. Once you get to college or higher level classes, or maybe a teacher who wants a little bit more out of this, that might not be most acceptable thing, and they probably want a little bit more description out of your graph title. For me, this is okay. We're not too stressed about this right now. Y versus X conveys enough information. I care more about being able to analyze the graph than the semantics of how we write the title. So these are the main things. Let's review real quick. Axis labels, X and Y, a best fit line, and a title. Those are the most important things. If you have those 4 things on a graph, you are great. You're doing just fine. From there, we can start to analyze the graph. That's going to come later. But let's take a look now at an example of a graph and then the software that I like to use for a graph, and I'll walk you through that real quick. So I will be right back. All right. So this recording is already over 15 minutes. So I'm going to try to make this brief. This is Graphical Analysis. It is a software provided by Vernier, Vernier. This software allows us to graph. We can manually enter data. We can also connect it to sensors and collect data that will then be automatically input. Through my physics classes, we do both of those. We do manual data. We do sensor data collection. We start out with manual data entry. Graphical analysis will do all of the things that we need it to do on its own. So we save some time rather than doing hand-drawn graphs. We go right into graphical analysis. It is a free software that you can just find by doing a quick Google search. If you're in my classes, it should already be on your Chromebooks. You just go down to your apps and search graphical analysis, which you can see right here. And that should just pop right up. The first time will take a little bit of time, but once you do, you get to this page here. We're going to start with manual entry. The last option here, manual entry. We click that. And it'll take a second to load. There we go. We get a graph on the left-hand side and a little data table on the right-hand side. From here, you're going to collect data in a lab most of the time, write data on a piece of paper, or type it into a Word doc or whatever it is, and then you're going to translate it into here. To be able to do that, you just click over in your data table. Let's say I have 1 and 1 and 2 and 2 and 3 and 3, 4 and 4 and 5 and 5, right? So this would be my X value. Let's just do something here. Let's say this is time. We measured it in seconds. And I just realized I didn't actually explain that. So I want to label my column here. So I'm going to click the 3 dots and then hit column options. So 3 dots next to where it said X, and then hit column options. And that allows me to change the name as well as put the units here. You can do some other things like change the symbol, change the color, all of that. You can mess around with that on your own. We don't need to be able to do that. Once we have our name and our units in, we just hit apply, and it automatically updates in our data table as well as our X axis. You can do the same thing for the Y value here. So I'm going to click then the 3 dots, then my column options. Go here. Let's call this distance walked. I don't know, just making something up, and we'll say that's measured in miles. Once I have that, I go ahead and click apply. And I have my data. Notice here, it automatically updates the y-axis. Now, if we look in the bottom left-hand corner, it has 1, 1 there. We don't actually see the 0, 0 point to the origin. In order to change that, we're going to go to the bottom left where it says graph options and click that. We'll get this menu here. We can edit graph options. In here, I'm going to change the left to be 0 and the bottom to be 0. We always want that to be the case. Okay, the left to be 0 and the bottom to be 0. You'll notice that the lines on the border of your graph get a little bit thicker, maybe a little bit brighter. I have mine in dark mode right now, so it shows up white. Yours might be black because it will just be a white background. However it is, but you'll notice that these lines get a little bit darker, a little bit thicker around the edge. But that's what we always want to do. We always want to be able to see that 0, 0, that origin point. In here is where we can add our graph title. So at the very top, see a blank space where we're going to type in our graph title. I'm going to go ahead and put in my y value, or my y variable rather, sorry, y variable, which is distance walked, versus the x variable, which is time. And I just get that by looking here. Notice I don't have any units in my graph title. I don't need units there. My units are shown on the axis. So distance walked versus time. Okay, so I have my y-axis, my x-axis, my graph title. The only thing now that I'm missing is my best fit line. Graphical analysis will do the best fit line calculation automatically for you. It'll save you a bunch of time having to hand draw it and then measure out the slope and everything from that. In here, we're going to click the bottom left button again, our graph options. It's going to open up our menu again. Instead of going to edit graph options, this time we're going to go to apply curve fit. Here we can apply all different sorts of shapes. If we click this little drop down, we see all sorts of different things that we can select. For us, for my physics classes, we pretty much only analyze linear. But again, you can see that we have all these different ones that we can choose from here. But I'm just going to stick with linear because it's the most simple, the most basic one that we're going to analyze here. So linear curve fit. Once I have that, we can see the line is drawn. If I were to just click away, this goes away. So I want to hit apply. So it plugs it in there. Once you hit apply, you'll notice we have this little box that pops up. This box tells us our information about our best fit line. Our best fit line, it is a linear relationship, a linear slope, a line. And so it's written in y equals mx plus b form. This is our math model, what we call the math model, y equals mx plus b. M is the slope. Down here, we can see the slope is 1. B is the y-intercept, our starting point, some people call it. In this case, B is 0. Won't always be 0. Sometimes it is. In this case, it is. And that gives us our math model. So if I plugged in my numbers here, I would have a math model of y equals 1x plus 0, or y equals x, right? My time equals my distance, or my distance equals my time. The values are the same. Once I have this, I'm ready to either copy it into a Google Doc, print it out, whatever it might be. In order to do that, I can go up here. You can save so that you can go back and edit. If you're running out of time in class, I would recommend, doing a quick save. Otherwise, you're gonna have to redo everything. You just hit your save as button and you can open it back up. But if you have it all done and you're ready to just copy and paste it over, you can hit this button here, export. Once this loads up, there we go. You can mess around with some different settings here. You can change the shading of different lines, the axis label size. You can make them a little bit smaller. If they're way too big, you can make them bigger. You can change the graph shape. Whatever it is, you can mess around with it. Not that big of a deal. But once you have it the way you want it to look, then you can either, again, save the image down in the bottom right corner, you can save image, or there's another button right to the right, 2 squares kind of on top of each other. You click that and you copy it to your clipboard. And then you can just hit Control V or right click and paste and put it into the document that you want. Makes it super, super easy. But that is the basics of graphing for physics and graphing how I like to do graphing for my classes and how I teach my students how to graph. Again, as always, if you have any questions, please feel free to reach out to me and let me know. But otherwise, thank you so much for taking the time to watch this video, and I hope you have a wonderful rest of your day.